Hello my dear students, welcome to my YouTube channel as Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is Hund's rule of maximum multiplicity. You can see the picture of Mr. Hund's on the screen. Before doing the Hund's rule, let us recapitulate the Aufbau principle. The Aufbau principle stated that various subshells are filled with electrons according to the increasing order of energies of the various subshells. That means the lower energy subshell get filled with electron first, then the higher energy subshells. So let me take an example. For example, I'm taking here I'm writing for example I'm taking the atomic number 10. It means we have to fill 10 electrons in various subshells according to their increasing order of energy. Increasing order of energy. Now let me arrange the subshells in the order of their increasing energy. The minimum energy is of 1s subshell. Then the 2s subshell has higher energy than 1s. Then 2p subshell has higher energy than 2s. Now let us fill the 10 electrons. We know that S subshell has a maximum of 2 electrons, so 1s will have 2 electrons. Then is a turn of 2s. Again it's an S subshell, so it will have a maximum of again 2 electrons. Then is a turn of 2p. Now 2p has 3 orbitals, so it will have a maximum of 6 electrons. Now let us represent the orbital of subshell in the form of boxes. So as S subshell has only one orbital, so I'm showing only one box for 1s. Now 2s subshell has again one orbital because S subshell always have one orbital, so again I'm drawing one box. Now the 2p subshell has 3 orbitals and the energies of 3 orbitals are equal, so that's also called degenerate orbitals. So I'm drawing 3 boxes together. Is one, the second box and the third box. So this is the 2p subshell with 3 orbitals. Now what's the name of these orbitals? The first one is 2p x, the second one is 2p z, and the third one is 2p y. This one is 2s and this one is 1s. Now here what's the point? That energy of 2px is equal to 2pz and energy of 2pz is equal to the energy of 2py. That means these 3 orbitals are degenerate orbitals. Now let's talk about the electrons. We have to fill electrons over here. Now let's talk about firstly 1s. In 1s we are having 2 electrons. In 1s we are having 2 electrons. So we will fill the first electron like this. This is the electron in an upward direction, or you can say that the first electron will have a spin quantum number of plus 1 by 2. Now let's talk about the another electron. Now the another electron will have a opposite spin like this. So spin quantum number will be minus half. So spin got cancelled. so it will minimize the repulsive forces between the electrons present in the same orbital. So it's a rule that when the two electrons are present in the same subshell, the both will have the opposite spins. That is, the one electron will have a spin quantum number of plus 1 by 2 and the another will have a minus 1 by 2, so as to minimize the repulsive forces between them. Now let's talk about the 2s. Now here again, the first electron will be filled as like this, with a spin quantum number of again plus 1 by 2, and the another electron will be filled like this. It's of reverse spin, so its spin quantum number is minus 1 by 2. So it's the same thing as that of 1s, we got in 2s also, but now we come to the 2p orbital for the degenerate orbital. Here applies the Hund's rule. Now what is Hund's rule? Hund's rule states that in case of filling of electrons in degenerate orbitals, firstly all the orbitals gets one electron each with plus half spin. After that, pairing will start with electrons having minus half spin. Let me talk about the word pair. Here, let me take a different color. This both electrons with the opposite spins will be called as pair of electrons. This is also a pair of electrons with the opposite spin. But in case of degenerate orbitals, what will happen? Firstly, all the orbitals will get one electron each with a spin quantum number of plus half. That is, we have to fill 6 electrons in the 2p. So this is the first electron with plus 1 by 2 spin. This is the second electron with plus 1 by 2 spin. And this is the third electron with again plus 1 by 2 spin. So that means firstly all the orbitals got all the 3 electrons with plus half spin. Now pairing will start. Now let's talk about the fourth electron. Where fourth electron will go? Fourth electron will again come to the 2px orbital with minus half spin. So that's the pairing started. Now fifth electron will come in 2pz with again minus half spin. And now sixth electron will enter in the 2py with again minus half spin. So we got the 3 pairs over here, and the spin of all the electrons got cancelled so as to minimize the repulsive forces between the electrons present in the same orbital. So this is the Hund's rule. So now let me write the Hund's rule. Here I am writing Hund's rule stated that in case of filling electrons in degenerate orbitals, comma, firstly all the orbitals gets one electron each with a spin of plus half. After that, pairing of electrons will start, with electrons having minus half spin. So as to minimize the interelectronic repulsions, so as to minimize the interelectronic repulsions between the electrons present in same orbital. So that was the Hund's rule. So Hund's rule says that in case of filling electrons in degenerate orbital, firstly all the orbital get one electron each with a spin of plus half. After that, pairing of electron will start with electrons having minus half spin, so as to minimize the interelectronic repulsion between the electrons present in the same orbital. Now let me re-revise you this thing again for the 2p6. I'm writing it again. That was 2p6 in the above example. So we have to take the three orbitals of 2p, and we know that these three orbitals are degenerate orbitals. That is, it is 2px, it's 2pz, it's 2py. What's degenerate stands for? That the energy of 2px is equal to the 2pz is equal to the 2py. So how we have to fill the electron in the degenerate orbitals? According to Hund's rule, firstly we have to fill one electron each in the all orbitals with a spin of plus 1/2. So we got the 3 electrons. So now here we are left with 3 electrons now again, because we have to fill the 6 electrons. So we got the 3 electrons. Now fourth electron will go like this with a spin of minus half. Now it's the fifth electron with a spin of minus half, and it's the sixth electron with a spin of minus half. So that's the Hund's rule, that firstly we have to fill the electrons for the, it's like firstly we have to fill electrons in all the orbitals with a spin of plus half. After that, pairing will start. So firstly all the orbitals, it's 2px, 2pz and 2py, firstly all the orbitals will get one electron each with a spin of plus 1/2. After that, pairing will start with the electrons having the spin of minus 1/2, so as to minimize the repulsions between the electrons in the same orbital. So that was the Hund's rule of maximum multiplicity. So I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.